some activity-based learning on interrupts. So already we finished the theory concepts regarding interrupts. So now we are going to learn with the topics covered under interrupt section. First, I will pose some questions regarding interrupts whatever we finished in the previous section. So those are the questions. First question I am asking is, what is an interrupt? The question is, what is an interrupt? And what are the possible sources of an interrupt? Means how the interrupt will generate for the processor. The next one is, what is the response of a processor when an interrupt occurs? If an interrupt occurs, how the processor will handle the interrupts. The next one is, what happens if an exception occurs? Exception means it is a software interrupt. What happens if an exception occurs? And one more, how nested interrupts occurs in the processor. And last one, what are the applications of NMI, non-maskable interrupts? So these are the questions I am asking you. So make a group of 3 members and discuss with yourself. I am giving you only 3 minutes. Then we will go for the possible solutions for the questions. Got it? Now, in a bench, you 3 people discuss with yourself and then I will ask the questions. Got it? Discuss yourself. Now your time starts. Don't discuss with others, only you need to discuss. interrupt means it is an immediate service required by the device, the peripheral device, from the processor. Is there any real time example for that? Anyone? Real time example for an interrupt? Yes.
I'm going to college.
Yes.
Because I'm going to college in the day we go to bookstore.
Okay.
And then the student interrupt. Again, our day agenda is to go to the college.
Okay.
Meanwhile, the student interrupt. Then we go to the station.
Yes. Very good. Any other? Any other? So when class is going on, if Sarkar comes, what happens? So there is interrupt in the class. Okay. So there is interrupt means an immediate service required by the device, the peripheral device, the external device. So from the processor, microprocessor. So coming to processor technology, the examples are what? Interfacing a USB pen drive. Okay. So while the system is doing some other task, you are inserting your pen drive. So this inserting a pen drive means getting some external device, connecting external device. So this is interrupting the original task. So that's called as an interrupt. Okay. So now the next question is, sir please. Video class. Video class please. Video. Yes, what is the second question? So what are the possible, means what are the different sources of interrupt? Yes, so now we can disturb the processor in only two ways to interrupt. So means what are the processor, whatever is currently doing, so that should be suspended by either only two options. One option is either through software, meaning through program itself, or through hardware. The software means you can generate with some instructions, interrupt M, where it is an integer, it is having the value 0, 0 to M. So with the instruction itself, we can interrupt the processor. So the instruction is either interrupt M, where it must be 0, 0 to M. So with this, total how many interrupts are there? M equal to 0, 0 to M, 0, 0 to 255. That is total number of interrupts available is 256. And that is varying from processor to processor, and it is only limited for 8086 processor. Clear? So with the instruction itself, you can interrupt the processor. So this type of interrupt you can call as a software interrupts. The one more way of interrupt the processor is hardware. So that is the hardware signals, and 8086 supports only two types of hardware interrupt source. So those are INTR as well as NMI. NMI is non-maskable interrupt. Here, so means only two sources for getting an interrupt signal from the hardware. So what is the difference between these two? Clear? So we'll discuss the difference next. So now the sources are not only either to software, and that is only to instruction. Software means the programming itself. With the program is not instruction. The instruction itself, if we interrupt the processor, so that type of interrupts are called as software. And if we interrupt the processor with some external signals, so those type of interrupts are called as hardware interrupts. Hardware sources are only two, and software sources are around 256 total. Is it clear? Yes? So what is the next one? What is the response of the processor? Got it? What is the response of the processor if an interrupt occurs? Okay, interrupt occurs, what to do? Means before interrupt, the processor is doing something. Before interrupt occurs, the processor is doing some task. If an interrupt occurs, what is the interrupt? It is an immediate service. It should be having some ISP priority than the existing one. So if it occurs, how the processor can handle it? both are loaded with the new values. And that should be from IVT, interrupt vector table. I invite you to that. Okay. See, when the interrupt occurs, first thing is, if before interrupt occurs, you are doing some main program, main task. This is your local task. While you are executing a program, so there is a sequence of instructions you want to execute. Whenever interrupt occurs, the execution break up. Whenever interrupt occurs, the execution should break. But again, after finishing the interrupt, it should continue the remaining parts. Once the interrupt occurs, you should go to solve for the device. Okay, while you are playing a movie or song or whatever it is, meanwhile you insert a pen drive, open the pen drive or copy or whatever it is, do some task. So before doing that, you are doing already playing some songs earlier. So that should be suspended and go for solve for the pen drive USB device. So that is one thing that is required in service for the processor. Once the service is finished, then again come back and continue the remaining part of the program. So how it is handling means, so once you interrupt your program, then go for solve for the device. Again you should come back and continue from where it is suspended only, not from the beginning. The process should continue from where it is suspended. So that is the reason the next instruction addresses are stored in the CSN IP. The program master should execute with the based on the values stored in the code segment this time. IP is also called as a instruction pointer program counter. The function of that is always pointing to the next instruction to be fetched. What is the IP is always pointing to the next instruction to be fetched. So now these addresses are present in CSN IP. Now we are going to execute new part of the program. But this program, once it is finished, again you have to get back to this one. How to get back? If you copy this CSN IP, copy to the new value, this will be lost, overwritten. So that is the reason while getting back these two addresses are required. So those are copied onto the stack. So first we are copying flag register. The flag register purpose is it saves the status of the current operations. So if you enter into this one, because the operations made on this interrupt service routine, so the flag register content may change. For that reason, once interrupt occurs while moving to the service routine, first it will copy the flag register onto the stack. Next it copies clears the TF and IF. The purpose of that is internally, initially, the default by default 8086 processor disabled, it doesn't support nested interrupts. Nested interrupt means nested means it is an interrupt within the interrupt. Once you are executing the main, while interrupt occurs, go to the main interrupt. So from the interrupt again, if one more occurs, again you have to go there. It is priority based. So that is called interrupt occurs within the interrupt, that is called as a nested interrupt. Default it doesn't support any nested interrupts. If you want to enable, you can enable within the interrupt service. Based on the program requirement, default it is doesn't support it, but if you want to support, if you want to allow, you can enable the interrupts. Clear? So now, and one more is copying the contents of CSC. So these two are required here. While getting back, the new addresses are required. So the then CS value should be copied onto the stack, and the next copy is IP. And next, finally, whenever you want to execute this new part of the program, that you can call that one ISR, interrupt service routine. So these addresses are present in IVT. So this must be copied onto CSN IP. Then only this will execute, this part of the program will be executed. And this address is present in IVT, interrupt vector table. So that is the reason once all these are copied onto the stack, this CSN IP registers are loaded with the new context of this address. So that must be present from IVT, interrupt vector table. So once based on this, once you start the execution from here, it will finish. Until it finish here only, once it is finished, then the previous contents you have to get back. BL. If BL performs AX by BL. So now my value for AX is 1, 2, 3, 4 X and the BL value is 0, 1 X. Assuming the values 1, 2, 3, 4 X for AX and BL with 0, 1 X. So once the division is performed, you will get two contents. Those are one is quotient, one is remainder. So now, if the source is 8-bit, BL is 8-bit register. If it is 8-bit, where the quotient is stored, where the remainder is stored? Quotient is stored in AL, remainder is stored in yes, but both are 8-bit size. Is it clear? Now, perform 1, 2, 3, 4 by 1. 1, 2, 3, 4 is the quotient, remainder is 0. Okay? So now, 1, 2, 3, 4 is the quotient that should be stored into AL. But 1, 2, 3, 4 size is what? How many bits? 16 bits. It should be stored into 8-bit register. Is it possible to store 16-bit data in 8-bit register? That's not the case. One more case is, if I want to make division with 0, my content, BL content is 0. If it is 0, what happens? It's undetermined. Is it possible? So denominator division, denominator must consider not 0. Other than 0 any value. But if it is 0, that should comes under undetermined. Okay. So in both the cases, so when quotient is 2 hours to reach the destination, either 0. In both the cases, it generates interrupt. So that interrupt we can call it as a divided by 0 or INT 0. INT 0. If you write INT 0, it will execute. Or if you write divide BL with these values, both the cases it will generate an interrupt. So that type of interrupt we can call it as an exception. So if this happens, what we are trying to make up to this instruction is okay. Before execution instruction is able to syntax, everything is fine. But if we execute this one, it will generate some problem. Syntactically correct, but logically there is a wrong. So if that type of cases occurs, how to handle those interrupts? So that should be decided by the manufacturers. So if exception occurs, how to handle the exceptions and decided by the manufacturer. The manufacturers are providing the solutions. Then automatically they will provide. If manufacturers are not providing the solution for that, the program has to take. The program has to write the solution if that type of exception occurs. What is it? Is it clear now? Okay. What's the next one? So, what happens if, how lesson interrupts are executed? So now here, from main program, while you are executing a main program, at this point, you will enter occurs. You will move towards, this is ISR. So while you are shifting from here to here, what happens? This is the cases. Okay, so these are all copied on the stack. Now, while you are coming from here to here, what happens here? IF and DF both are clear. If interrupt flag is clear, there is no chance of getting an interrupt. You are simply disabling the sources of interrupts. If interrupt sources are disabled, there is no interrupt from external or internal also. Yes. So now, default it is clearing. By default it is disabling. But if I want to make an interrupt within the interrupt, here I want to set an interrupt flag. If I want to set an interrupt flag. So if you set an interrupt flag here, now there is a chance of getting an interrupt over this ISR. So during this phase, at this phase, So now, what do you mean by the maskable and non-maskable? What is the difference between the maskable and non-maskable? The chance of occurrence of an interrupt disable, that can be maskable interrupts. If it is not, there is no chance to disable the interrupt source, so those type of sources are called as a non-maskable interrupts. It means the occurrence of interrupt is disabled. The previous circular came. If you close the door, there is no circular. So that type of interrupt is maskable. There is a chance of getting disturbed. The class is getting disturbed with the circulars. So if you close the door, what happens? There is no disturbance, no interrupt. Simply we are disabling. So that type of interrupt, the door is interrupt source for us here. So that can be disabled means simply close the doors. So if there is a closing, disabling chances available for interrupt. So those type of interrupts are called as a maskable interrupts. Non-maskable means if the interrupt occurs that cannot be disabled by the program. There is not within the hands of the program. So those type of interrupts are called as a non-maskable. So what are the specific applications of non-maskable interrupts? The primary thing is what in organizations or industry what happens? Main thing, short circuits, firings. So whatever the short circuits or firings or damage, anything happen, immediately the person should provide what? Immediate first switch off the power supply. With that we can reduce the damage. So now the primary, the circuits, the entire circuit output should be given to the non-maskable interrupt. In the interrupt service schedule we are running some program. So if anything happens, immediately switch off the power supply. The range should be cut off. Then water supplies. Provide, if it is a firing case, the tank should be open. And near to, send an SMS to nearby police station or whatever it is, either management or the maintenance department or whatever it is. Send some to GSM. So means the GSM everything, the program required for that, everything should be loaded to the interrupt service schedule, the NMI interrupt service schedule. So once the interrupt, when the type of interrupt occurs, immediately it will call an NMI. So in the NMI interrupt service schedule, so this part of the program will be available. Power supply should be on, send the SMS to police station nearby, or health station or fire station, SMS to some maintenance persons, security officers. So all those are loaded into the NMI service schedule, non-maskable interrupt service schedule. Okay. So these are the interrupts, means how it is handling the interrupts, what are the types of interrupts, sources of interrupts. Okay. So other than this, any other doubts? Any more? Yes. Okay. So now, what is the difference between the hardware and software interrupts? So now, what are the sources of software? It is INTM, where it is 002 FF. Where it is 002 FF. Now, what are the hardware sources? One is INTR and other is NMI. So this is what software interrupt, this is hardware interrupts. What is the difference here? Interrupt means what? First of all, immediate service required by the device. Now here, software means based on the instruction it will generate an interrupt. And this is hardware means through external source it will generate an interrupt. Through external source it will generate an interrupt. And one more is through software interrupt means we can determine when the interrupt will occur. So now if I am writing some program, it is having 100 lines of, this is 100 lines of program. Where to generate an interrupt? At what point I have to generate an interrupt? So that should be predetermined. Here I am writing some INT file. So after these three instructions, this is a software interrupt generated. This part of the writing of software interrupt should be hands off, within the hands of the program. Where to generate an interrupt will be decided. But coming to here, NMI or INTR, that should not be decided. Once you are executing this part of the program, this type of interrupt may occur at this point or this point or this point. The occurrence of interrupt cannot be determined for hardware. But So before entering the exam, if you want to call, then for someone you can call it. That can be predetermined. But while the writing exam, you are expecting that no one should call. But that cannot be determined by the program. Negative and may not be. Is it clear? So that is the difference between both software and hardware. Any other? Yes. Vector and non-vector. So first of all, this is an interrupt. Again, the previous already finished. There is CS and IP. Both are copied to the stack, and new part of the program CS and IP included. Got it? So this part of this address, the ISR beginning address is there. So that address we can call as what? Interrupt vector address. So the interrupts provided with vector address, those are called as vector interrupts. Interrupts provided doesn't provide with vector address. Is this predefined addresses are provided for the interrupts? Those are called as vector interrupts. Those are not provided with the predefined addresses called as non-vector. Means providing address initially itself. There is vector interrupt. You are not providing any initial address, so that type of interrupts are called as non-vector interrupts. Yes? Any other? Yes. Okay. For vector address interrupts already provided in the table, that is IVT, interrupt vector table. For non-vector, how to provide address? Because if you want to execute some program, that program must be stored in the memory. If it is stored in the memory, then only it is possible to execute. But in which memory? The part of the program starts the execution, means stored into the memory, from which location onwards? I assume this is an interrupt service routine. I want to execute this interrupt file. It doesn't have any vector address. Assume it is a non-vector interrupt. If I want to this program, to execute this program, if this interrupt occurs immediately, it should go there. How it should go in there? Means this vector address doesn't provide in the vector table. Vector address provided in the vector table is vector interrupts. For non-vector, there is no address provided in the table. How to provide? So this is only possible. This is possible only for hardware interrupts. So that hardware is through only INTR, not for the unit. All the software interrupts are vector only. Even memory is also vector interrupt. And only INTR is a non-vector interrupt. So for this hardware, if you want to interface any device to this hardware INTR address, with the program itself, you have to provide the vector address where to execute, start the execution. Where to start the execution for ISR. So that is possible only the program itself. With the program itself, you have to provide some address. So if this type of interrupt occurs, start the execution from which location onwards. So that is possible only by providing the address through program, and the program should be interfaced with the interrupt rectifier. Got it? Any other? How to clear? So now for clearing interrupt tags, we are having some instruction, that is clear. Means clear interrupt tag. If you want to set enable, so default it is clearing. While interrupt occurs, you are moving from main program to subprogram. It is already cleared. If you want to set to enable the multiple interrupt, to set the interrupt tag, the instruction you are using is SDI, set interrupt tag. So with this, it becomes I equal to 1 and this increments I equal to 0. This is disabling, this is enabling. Any other? Any other? Okay? So now, small assignment. Take the papers out. First question. Right, only for 3 minutes. What are the possible sources of an interrupt? What are the possible sources only 3 minutes. Make it fast. Write your details on the page and submit. Finish. Just write your details on the page and then the papers. Very fast. Yes, learn it. Learn it. Correct yourself. Finish.